plus 4 if x is less than 1. Okay, and then x plus 2 if x is greater than 1. So that's going to look like, let's put 3 here, and it's going to go kind of like this. All right, so my scale's not perfect, but that's pretty close to what it looks like. Now, is there a way then to tell me what f of 1 has to be to make it continuous? What if f of 1 was 5? You would be including this point right here. Say we filled that in. Would that make it continuous? No. What if f of 1 was 3? We would be including this point right here. Would that make it solid and continuous? No. Well, because of the gap there, because these are just disconnected, it doesn't matter what you make f of 1 be. It doesn't matter where you include a point at 1. It's not going to become continuous. All right? Okay. So this one is not possible. So we'll give our answer like this. That function, the way it is, there's no way you can redefine a point there at 1 to make it continuous. This one you can. You just had to move that point down a little bit. But here, you can put a point here, you can put a point there, you can put a point somewhere in the middle. That's not going to make it one solid, continuous graph. Just not possible. So this one, no matter how you redefine it, we'll say it's not possible to be continuous at 1. It just can't happen. Okay? To answer the question directly, what does that n have to be? F of 1 needs to be n. It just means there's no solution to n. So we could answer it either way. Okay? Both of these would be a response to that. All right. So we can probably do one more real quick. Okay? So this one sounds like the other one, but I just wanted to give one more quick example. All right? Something to kind of complement the other one. So this one is not continuous at 4. F of 4 is undefined. That's one reason why it's not continuous. But let's sketch it real quick. Here's 9. Here's 4. Can you agree with me about this? There's 2x plus 1 if x is less than 4. That very last point, 2 times 4 plus 1 is 9. It will go up to that point but not include it. This other one, x plus 5 from 4 onward. Where's our first point there? 4 plus 5 is 9. That will also be open. And then it will continue, kind of like so. So again, the scale's not perfect there, but that's pretty close. All right. What answer to make this is not continuous, right? There's a hole right there. It's not continuous at 4. The function is not continuous at 4. You're looking at it. It's not. But what would f of 4 have to be to make it continuous at 4? If f of 4 was 9, like say that you included that point, we would become continuous. Then it would be solid. So we'll say, all right, well, you need f of 4 to be 9 to be continuous at x is equal to 4. If the function was such that 4 for x gave you 9 for y, that point would be on there, and it would be continuous. Can we agree about that? What's another more direct answer to the question? The answer, I wanted to say this because it's a little more descriptive about what I'm saying the answer is, but the answer just said, tell me this number n. F of 4 is equal to what to make it continuous? Well, it turns out if n was 4, if n was 9, then that function would be one solid continuous graph, and it would be continuous at 4. Okay, so you can answer either way. I want you to see that they're both equivalent responses to that question, though.